Hey, hi everyone, good morning. Let me share my screen. Okay, so in our last class, right, so we discussed yeah, very good morning. So we discussed about the triggers and then subqueries, right? So correlated subquery and then non-correlated subquery and then types of queries when we'll call it as subqueries and all. So and also we have seen the differences between the correlated subquery and the non-correlated subquery. So all these things, okay. So what is single row based subquery and then what is multi row based subquery? So what we will use for the single row based subquery and then what we will use the multi row based subqueries, and also we discussed about the triggers. So in that we also discussed about the DML triggers, like we'll call it as the after triggers also. And what are the magic tables we have? What are the magic tables we have in our database case?
Insert delete.
Yes, inserted and deleted. Not insert delete, inserted and deleted. So both are only inside stored procedure only we can access, but that we cannot access outside the stored procedure. Are you getting it, guys? See here, you can go and then select the values inside the stored procedure only. But if you try to execute this, if you try to this one, take the outside the sorry, not stored procedure trigger. Okay, if you try to select this, select star from this deleted one, so it will not work. It will not work. Okay, so these are called a magic tables. Like what deleted will have? Deleted will have the old records. Deleted will have the old records, like deleted records, and updated and inserted records will be there in the inserted tables. So if there is any event in occurred on any other table, so those will be captured by inserted and deleted tables. Those will be captured by insert and deleted table, and uh, where you want to audit the information, that will be kept, that you can insert into this table. So that's what we discussed about the triggers. Hope you are clear with the triggers and the subqueries, right? So it's very simple, right? Now today class is normalization. Today class is normalization. What is normalization? Normalization is simply we can say it is a database design, guys. It is a database design. So if you want to organize your data properly, then we'll go with the normalization. Okay. So you need to remove the redundancy of the data. What is mean by redundancy? Why we need to remove the redundancy, and then so what is the problem before normalization, and then how normalization will solve the problem? Are you getting it? So what is normalization, and how this normalization will solve the problem, and then before normalization what would be the problem, and after normalization how it will be solved, and all we're going to discuss. So here totally six types of normal forms we have, but mostly every organization will use mostly three NFs. Okay, three normal forms only. They will not go with the like all the normal forms, but mostly every organization use, like 95% people will use the you know third normal form till third normal form actually. Okay, so what is normal form, what is normalization? Here we have the definition. Normalization is a technique of organizing the data multiple related tables to minimize the data redundancy, to minimize the data redundancy. So what is data redundancy? The repetition, like duplicate data is nothing but a data dependency. Data. Okay, let's go here. Let me give a simple example so that you will understand very clearly. Just a minute, guys. Okay. So let me give a simple example so that you will understand very clearly. So if you go here, right? If you go here, like so, we have the employee ID, employee name, gender, salary, and then so department, and the department head, then head. Okay, this part is right. So whatever the department part is there, right? So it is repeating. Yes or no? So if I insert one more record, and again this information will be repeated. So this IT, and then John, and then so department head is John, and then the department location is head, like London, right? So this will be repeated. This will be repeated. So if we have the thousand millions records, then definitely this part will be repeated. So this is nothing but a this repeated data is nothing but a this repeated data is nothing but a what redundancy. Okay, this repeated data is nothing but a redundancy. Is everyone understanding what is redundancy? Okay, so because of the redundancy, so what is the problem with the redundancy? Because of the problem of because of the redundancy, like disk storage space, actually lot of disk storage space it will take. Yes or no? It will take the lot of disk storage space. And then also data inconsistency, you will not have the consistent data. Okay, and your DML queries means insert, update, delete. Insert, update, and delete will be slow. Why? Because suppose if you go and then update wherever you have the IT head John, like so you have updated to Joe, like suppose you have millions records, so somehow in between it got failed, and then so almost um, 90% of records are updated, only 10% records are not updated. So like 90% will be Joe, only 10% will be John. So that means it will be inconsistent, right? And your DML queries will be very slow. It will be become a very slow. Why? Because even if you want to insert a data and deleted data or update any data, so you have to update, like so you have to update all these records. Or if you want to delete this record, like so if you delete the so if you delete this IT department information, so if you want to delete the IT information, like so even that IT related records also deleting, right? So you are also losing the employee information. Yes or no? If you want to delete any record IT related information, you are also losing the employee information as well. Is everyone with me, guys? Okay, so data inconsistency, you are not. So then this is the problem actually. So how to solve this problem? Okay, so everyone is understand the problem, right? So it is taking more space, and also data inconsistency, and and also and also it will and also it will DML
Delete the
queries,
complete record.
it will also DML queries will be very slow, right? So like insert, update, delete will be slow. But how to solve this problem? To solve this problem, right? So just we need to split into two tables actually. We need to split into two tables. So how to split into two tables, like so? Just take this one, and then you need to have the department ID here. Department ID. So in this department ID, just let me go here. So whenever you have the IT, so you are going with the one, and then HR2 and IT1, HR2 and then IT1. So you can also split into another table, that is a department table. So in the department tables, will have the department ID. You'll have the department ID. So again, department name, and then department head, and then department location. Okay. So now if you go and then if you go and then Okay, so now if you have the department ID, how many departments we have? One and two, right? And then what are the department names? IT and HR, right? And what is the department head? John and Mike, right? John and Mike. And then what is the department location? London and Sydney, right? Okay, so now, so the thousand million records will be only two records. Yes or no? The thousand million records will be two records only. It is when you going with the normalization, it is saving the lot of disk space, lot of disk space. And then Even your updation also, like even if you want to delete any department record, easily you can delete the record. And even if you want to update any department head, easily you can update. Or even if you want to insert, it will be easy. Agree? Hello? Agree or not? So that is the reason we'll go with the normalization. So the problem with the normalization is disk space wastage and data inconsistency, and then DML queries will be slow. Okay. So here I have written that those points. The problem with the redundancy is repeating the extra space and then leading the insertion and deletion update and issue. And the problem, like we have the display wastage and then data inconsistency, and then DML queries will be slow. So once you reduce the data redundancy, data redundancy, then definitely, okay, so everything will be simplified. Yes or no? So this is the normalization. Okay, this table we converted into this normalized form. So once you convert it into the normalized form, so it will be easy to insert, update, delete. And then there is no repeated data. So you will have the relationship between this table and this id and then this id. So this is a primary, so this is a foreign key and this is a primary key. Okay, this is a parent table and this is a child table, right? Clear? Normalization issue, how it is solving the problem and all, everyone is clear, guys? So we'll discuss about the three normal forms. Okay, we'll discuss about the three normal forms. What are the three normal forms are there, and then how these three normal forms will solve the problems and all. We'll discuss now. Okay, so first first normal form. Okay, so if you go with the first normal form, like there are three rules actually. The first rule number one, the rule number one, data data in each column should be atomic and no multiple values and then comma separated by comma. Suppose for example, if you have the table like this, if you have the table like this, and then it is having the department name, and then it is having the employee name like this. Okay, employee name like this. So what is the first point is saying? The first normal form, first point, first rule number one. So it should not have the comma separated values. It should not have the comma separated value. It should have the unique values. So as for the first rule, then what we need to do, we need to go here and then say that, like, so we have the IT and then HR. So as for the rule number one, what we can do, like we can go with the employee one, employee two, and then employee three. Okay, you can give the employee one and you can give the employee two, sorry, employee two, and you can also give the employee three, and let's remove this. Okay, so here my employee one is Sam, right? My Sam, employee name is Sam, and then employee name is Mike, and then Mick, right? And here we have only Pam. Okay, only one employee, so we have Pam, right? So we have Pam. So this is like a first normal form. As for the first normal form rule, so this is the way we are doing. But again, there is a second rule. What is the second rule is saying? So the table does not contain any repeating column groups. Repeating column groups means this employee one, employee two, and then employee three is repeating, right? Hello, this is repeating. So as for the second rule, you should not have the repeating. So if we have a more than three employees, the table structure change, right? And then if you have a less than three employees, so wasted disk space, right? So if you have, like if you have a more than three employees, like if you have a more employees in a comma separated, definitely, so it will take more disk space. And if the problem with this one, what is the problem with this one? Like when you have the comma separated, it is not possible to select or insert or delete the data. Yes or no? Okay. What is the problem with this one? So when you have the comma separated, even if you want to select or insert or update and delete, it is if you want to delete only one employee, is that possible, guys? If you have a comma separated, hello, if you want to update any one employee, is it possible to update that? Okay, this is the problem with the non-atomic. This is the problem with the non-atomic data. So you cannot go and then update and then delete and then insert the data. So because of that, what we are doing, so we are going with this way. So now the table structure has been changed. So as for the requirement, but so it is wasting the disk space. Yes or no? And here also repeating the column groups, right? It is repeating the column groups. The problem with this one is this structure is it is repeating the column groups. So these three, employee one, employee two, all these three are repeating the column groups. Then how to define this? How to define this? Very simple, guys. So what you need to do, go, you need to go with the department id. So department id and then department name. So department id and then department name. Okay, so in department id we have one and then two. One is it, one is it, and then two is hr. Okay, so one is it and two is hr. So like this you can divide, and then so you can go with the employee number. Okay, department id, so you can go with the department id, and then you can go with the employee name. Okay, employee name, emp name. So so in first department, who are the employees are there? These are the employees are there, right? So these are the employees are there. So now, so you have the employees like in first department, like department one and one, and then to second department you have the like PAM, right? PAM, yeah, clear, guys. So and we'll also have the we'll also have the this is the foreign key, this is the foreign key, and this is the primary key, this is the primary key. So now we can say, now you can say this is the first normal form. Now you can say this is the first normal form. Okay, so what is the rule number one? Rule number one, you should have a atomic values, and there should not be any comma separated values. Okay, that is the rule number one in the first normal form. And then second normal form, so you should not have, like when you are saying this, so we are converted to this, right? Again the rule number two is that, so you should not have the repeating column groups, right? So immediately we have done this way. So this is the first normal form, this is the first normal form. Clear, everyone? What is the first normal form? So these are the three rules we need to identify. So the rule number three is identify each record uniquely by using the primary key. So in primary key, we are identifying each record uniquely. Okay, those are the three rules we are followed, and then we created the first normal form. Guys, is everyone clear? What is the first normal form? Super, awesome. Next one, second normal form. Second normal form means, like, what is second normal form? Second normal form means, like, so the rule number one, first the table should meet all the conditions of first normal form. Okay, means all these conditions, like table should be, atomic, and then no multiple values comma separated, and then table does not contain any repeating column groups, and then identify each record using a primary key. Okay, so should meet all these conditions. That is the first point. And then second point is move redundant data to separate table. Move redundant data to separate table, and then create a relationship between those tables using the foreign keys. Okay, suppose if you go with the first table example, if you go with this first table example, okay, so this one, right? So this one, right? So like this is your table. Just imagine that. Like, so this is your table. So after taking this table, so this is in, like, it is not in a normalized form. But if you convert this into the second normal form, like you need to remove the redundant data into separate table. You need to you need to take this data into separate table, right? So if you want to take that data into separate table, you need to have the department id. Okay, department id, and then department name, and then department head. Okay, department name and then department head. So this you need to take into separate table. Okay, that you need to take the separate table. Okay, so now what is the like 1 and 2? So your departments are like 1 and 2, and so IT and then HR, and department is John and Mike. John and Mike, and then London and Sydney. So this is your second normal form, guys. Okay, and then also you need to have a separate employee table, separate employee table, and so this one is a primary key. Actually, this is a primary key, and then whatever the department ID you have in employee table, so that is a foreign key, guys. Okay, so here you will have the 1 2 1 2 1. Like 1 means IT, 2 means HR, right? So 2 means HR. Let me increase the font size of this one. Okay, so now this is the foreign key. So you will create a relationship between this one and this one. So that is the, like, this is called a second normal form. So what is the second normal form? It should meet all the criteria, and then table should meet all the conditions of first normal form, and then moving redundant data to separately. So I moved the redundant data separately and then created a separate table, and then create a relationship between the tables using the this foreign key and then primary key, this foreign key and then primary key. Okay, so this is all about the normalization, guys. Okay, this is all about the second normalization. Okay, so next, third normal form. Okay, what is third normal form? Let's go with the third normal form points. So it should meet all the conditions of first and second normal form, and columns are fully dependent with the primary key. What is mean by this? Okay, what is mean by this? So here, like, so as for this table, if you take all this table, like this table, so till here you have all the columns, and then so even you also have the department ID, so you have separated the department table separately. But the thing is, so what the point is saying, all the columns, like, so whatever the primary key is there, so whatever the primary key, so here is an employee table, employee ID is a primary key, and then department ID is a foreign key. Okay, it's relating to the department table, right? So department ID is a foreign key. Okay, what the rule number, like for the this one, like third normal form rules, like it should meet all the criteria of first normal form and then second normal form, and then third normal form is means, like it should be fully dependent with the all the columns, whatever the columns are there in this table, whatever the columns are there in this table, it should be fully dependent with the primary key. What is mean this? What is mean by this? So fully dependent with the primary key means, fully dependent with the primary key means, so if we have annual salary, right? So we have annual salary, so it is based on the employee. Suppose this is not based on the primary key, so even if you change the primary key, like it is not only only dependent on the primary key. If you change the person, so the person salary will change and then annual salary will change, right? It is not depend on primary key. So whether you employee ID will change or not. So if you want to use the same employee ID with the same person name, okay, same person name, like, or a different person name, and then their salary got changed, so if their salary got changed, then immediately the annual salary will be changed, yes or no? So if he has increased his salary like to some 6K, okay, if we increase like 6K, then annual salary will change. So it is not depending on your primary key, right? So based on your salary it is changing, based on your salary it is changing, right? So in third normal form, we should not have this kind of columns, we should not have this kind of columns. Clear? Okay, so all the columns should be fully dependent with the primary key. So when we change the primary key, then only it will change the values. So if you change any of the values, it should not affect the other column. If it is that is affecting, then you have to remove that column from the table when you want to go with the third normal form. When you want to go with the third normal form. Clear? Okay, this normalization concept is same for the Oracle, IBM DB2 and everything, guys. Okay, just you need to define the database, like, so you need to design the database, you know clearly, like simplifying the data, and then so it will be no avoid the, like, insertion, updation and deletion will be very very easy when you are going with the data like this. Okay, insertion, updation will be very very easy, and then also it will save lot of memory, and even your query performance also will improve. Okay, so this is mainly when you are going with the ETL operations. Okay, when you have the transactional database, so when you have the transactional database, then you will go with the normalization. Transactional database means, so when we have the OLTP, when we have the OLTP means online transactional processing. So that is called a OLTP. OLTP means, actually nowadays every business is maintaining two databases, guys. Every business is maintaining two databases. Let me go with this. Okay, nowadays every business is maintaining the two databases. One is OLTP. OLTP means normal database, daily transactions will be there. So daily transactions will be there. So here we'll have the um, daily data. Okay, it will not maintain any historical data. Actually, it will not maintain any historical data. It will have the daily data. Yeah, and there is one more database the people will maintain, OLAP. It is a very big database. This is called a data warehouse also. People will also call it as a data warehouse. It will maintain all years of data. Actually, it will maintain all years of data. Okay, but this will maintain only less than or equal to 2 years of data. Are you getting it, guys? So this is a OLTP. This is OLAP. Okay, so here it will have the less than 2 years, less than or less than 3 years of data maximum. But it's not more than 3 years of data. But here you will have almost 10 years of data. Okay, all historical data, all historical of data will be there. Historical data will be there. So here it is mainly used for the insertion, updation and deletion. So why they want to go with the insertion, updation and deletion will be easy. Why? Because this daily. So whatever the front end data is there, whatever the front end data is there, so this front end data, they don't want to stop this, like they don't want to affect the performance of the front end. Actually, they don't want to, like, suppose you vacated one room and then you are moving into the new room. So you have booked your movers and packers, right? You have booked your movers and packers. So now, um, no, this is not a correct example, but even if you want to maintain, like, so if whatever the data is there, so if you want to maintain this data like easily, like inserting very simple, then you need to go with the normalized form. Okay, so like when you have the like, suppose if you have the triple bedroom flat, right? If you have triple bedroom flat, if you want to, if you don't want to touch with the any so if you have a single room, what you will do, what you will arrange the dresses one by one, right? And then if you drag one dress in between dress, then the remaining dresses will be disturbed, right? Hello, the remaining dresses will be disturbed. But if you have a triple bedroom flat, and then the dressing table, like you have the hangers, and then each and every dress will be hanged, and without touching any dress you can go and then remove the dress easily. Yes or no? Okay, without touching anything. So that means the deletion will be very very easy. Okay, whatever the record you want to delete, so without touching anything you are deleting. Hello, without touching anything you are deleting, and then organizing the data, like if you, even if you want to insert the data, like it's very easy or not. So going and insert the data also without touching anything, you can go and then insert the data without touching anything. So without disturbing anything, without you know disturbing anything, you can go and then insert the data. So that will be very very easy when you are in a OLTP system. So the OLTP system is more normalized actually. So this is more normalized. It's like a snowflake schema, guys. Okay, same like a snowflake schema. It's more normalized. So because of the more normalization, you will have the more tables actually. So because of the more tables, like insertion, updation, and deletion will be very very easy. Insertion, updation, and deletion will be easy. So this mainly designed for the like insertion, updation, and deletion will be easy purpose, and more organized format, like so the data will be more organized format. So for that purpose, this OLTP is designed. This OLTP is designed. Then what is OLAP? OLAP means online analytical processing, guys. Online analytical processing, this is only for the analysis purpose, not for the insertion purpose, not for the delete purpose, not for the update purpose, only like select purpose. But here the selecting the data will be, it's not that much easy. Here the selecting data is not that much easy. So you need to join the all the tables, and then you need to like if you have the 10 tables, you need to join the 10 tables, and then you need to grab the data here and there, and then select the data. Definitely it will be slow. The slow, like the disadvantages here is the reading data will be slow. Reading data will be slow here. Okay, this reading data will be slow here, but though this is the advantage, this is disadvantage for the insertion, disadvantage for the like insertion, updation, and deletion. But advantage is that select, like it is mainly for the analysis purpose, right? So the select is the advantage. So it will be redundant data. Redundant data means it will club the all the tables, like so this kind of data is will be there in the, this kind of data will be there in the denormalization. Okay, it will be combined. So this department data will be combined here. So even though it will increase the disk space, it's not a problem, but it is mainly for designed for the selecting data easily. It is mainly designed for selecting data easily. So it's mainly for the analysis purpose. It is mainly for the analysis purpose. You are not going to delete any record, right? So what is the problem with the denormalized data, guys? So deletion is the problem, but so historical data you cannot delete, right? So history you cannot delete, right? History is a history, you cannot go and then delete that. So history we will not delete. So that is the reason we'll add the redundant data. Why will you add the redundant data? So if you want to perform your select operation fast, then you will go with this way. So that is the reason data warehouse will have the redundant data. Data warehouse will have the redundant data. It will be fully denormalized, and then also it will have the historical data. It will also have the historical data. But the thing is, the problem with this one. So we are not going to perform any delete operation. We are not going to perform any update operation. But insertion will be there. But when you have the insertion, it will be little slow. So we'll add the history. Hello, we'll add the history, but we'll not update the history. We'll not delete the history. So this will use very less actually. This we will use very less. Delete and update will use not even less case. Okay, we'll not use that. That is the reason we are adding the redundant data. When we are adding the redundant data, that select will be very fast. Is everyone with me, guys? So denormalization, like when the first data will be in a denormalized form. So that when we have the denormalized form, then the data selection will be very very fast. So even we discussed in the star schema and the snowflake schema, which one will be very fast and why and all. So snowflake schema will have a more normalized one. What is normalization? Splitting the tables based on the rules, right? Splitting the tables based on the rules. Like we discussed the rules, right? The first normal form and the second normal form and the third normal form and all. Yeah. So based on the rules, we are splitting the tables, and because of that, you have a more tables. Because of the more tables, it will have the more joins. Because of the more joins, the data reading is slow. But denormalization means what? Combining the tables. because of the combining tables, you will have the less tables. Because of less tables, you have a less joins. Because of the less joins, the data reading will be very fast. So this is a data warehouse case. Okay, this is a data warehouse. So here, like it will have the historical data. It's mainly for the analysis purpose. It's not for the insertion, updation, and deletion purpose. So this is a daily database. Like here we have less than like so every business will maintain the two databases. One is for the easy purpose, whatever the data is coming from the front end, so too easy to maintain the data, like insertion, updation, and deletion should be maintained easily. Then you can go with this data, and from there you will add the data here. Okay, from there you will go and then load the data here, guys, into data warehouse. Okay, so we'll discuss modeling also, like data warehouse concepts also. There you will understand, like, so what is this OLAP, and then why we'll go with the OLAP, and then how we load the data into the OLAP and all. So these are the some hope you got some idea, like what is the normalization, how the people, how we'll go and then design, and what is the purpose we'll design and all, right, guys? You got some idea or not? Okay, so now there are some case statements, guys. Okay, you can also use the case statements. So I didn't explain about the case statement, right? So just a minute. So in SQL Server, we'll also use the case statement. So when we go with the case statement in Power BI, we have the switch class, right? So we have the switch. So if we have the same like a switch only, case statement is same like a switch, guys. Okay. So let me go with the SQL Server, and we can also use the if. Okay, we can also use the if also there. So let me go with the new query. So we'll discuss if and switch, and then we'll close the class, guys. We'll discuss if and switch, and then we'll close the class. Okay, let's close with the new query. So most of the times we'll use the case statements. So if you have the employee table, let's go and then select the employee table. Select star from emp employee table, and then you can go and then execute. So here we have the salary, right? So here you can write the case statement. What is the syntax for the case statement? Syntax syntax for the case statement is case case when case when. So whatever the column, so if the column value is something, if the column value is something, and then return something. Okay, then you can return something. Okay, and then you can write n number of cases. So you can write n number of cases like this. So first we'll have the when, and then you can go with the next case. So when this column value is this, and then you can go and then this value, and then when we have the column value with this, and then you can write this. So even if you take this is a month number, so like we have so in our if you take this month number, if the month number is one, if you want to get the month name, so then if month number is one, then what is the month name, guys? January, right? So like this, you can, like, if the month number is two, okay, if the month number is two, if month number is two, then what will get this? February, right? So based on your case, like, so based on this, like, values, based on the case values, and then you will get the different results. You will get the different results. That's where we'll go with the case. Okay. So when we have the column and then values, and then if the value is something, and then return some value, and then you can go with the else and then end. So else, like the else part. Okay, whatever the else part you want to write, and then end. So this is the syntax for the case statement. Let me go with a simple example. Okay. Simple example. So we'll use this one only. We'll use this employee table, and then we'll write the case statement. Okay, we'll write the case statement. Let's go here. Select select employee ID. Sorry, we'll go with the from employee ID we have, and you can go with the comma, and you can go with the name, and then comma, and then salary, and then comma. So, and then department. Okay, so what I want to write is I want to use the case statement. I want to go with the new column, so that is the salary levels. Okay, I want to go with the salary levels. So if you want to, like, so what is the condition I'm going to write is, like, if the salary is greater than 70,000. If salary is greater than 70,000, it's a high paying salary. Okay, so if that is the case, and then if the salary is between, like, 50 50,000 to, like, between 70 between 70 and then 60, it's like greater than 70 is a high salary, and then between the 50 to 70 is a medium salary, and then, so if else, other than those criteria, like, so let me go and then write like this. Okay, so if you have greater than 70,000, if it is greater than 70,000, it's a high salary. Okay, high salary. And then if you have a between 5,000, greater than 5,000, greater than 50,000, greater than 50,000, and less than 70,000, less than or equal to 70,000, then it will be what? Medium. Like double, not double quotes, single quotes. Medium. Okay, so medium salary. Else it will be low salary, something like that. You want to write the condition. Everyone is clear with the condition, right? So that is the salary level. So let's use the case statement here. So case when. So what is the column name we are using? Salary. Yes or no? Salary is greater than 70,000. If salary is greater than 70,000, then what you want to write? What do you want to write? Then I want to write high salary. Okay, again you are going to write one more case one more case. So what is that? Like, if salary between, okay, if salary between, I'm using the between. If salary between, like, 50 and 70, 50 and 70, then medium, right? Then medium. Else 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 you can say it's a low salary. You can say it's a low salary. Yeah, low salary. And you need to write the end. After that you need to write the name. So whatever the column you are generating, you need to give the name. Alias name is a salary level levels salary levels. Are you getting it, guys? And then you can go and then execute this. The salary level separate column will be came here, and then you can go and then see, it is 50,000 is there, it is a medium salary, and then below 50,000 it is like a low salary, and then this is also low salary, and then this is a medium salary, and then this is a medium salary, and then this is a high salary. See, are you getting it, guys? So this is a high salary, and then this is high salary. So like this, you'll use the case statement, and then so you can also change it to, like, even in interview people will ask, like, so if you have the male and female, the gender is there, like, so there is a employee table. Select star from EMP table is there. So here we have the gender. So we have the gender, right? So where is the gender? In which table we have the gender? Customer table. Okay, let me go with the adventure works DW. So there in a customer table we'll have the gender, right? So let's go with the new query and go to the tables. And so let's select the database. Select the database name as adventure works DW 2019. And then you can go with the customer table, dim customer. Where is the dim customer? So here is the dim customer. And then you can drag the dim customer here, and then you can write the select. Okay. So do we have the gender here? Yeah, here is the gender, right? So what simply people will they will ask you, wherever you have a male, change it to female, and then wherever you have a female, change it to male. Okay, so this is the interview question. People will ask this interview question. Okay, so simply you can write the case statement where case when gender is equal to male, then you can go with the female. So you have to write the update. So case statement with the update, guys. So if you go with the update, then it will be update. Are you getting it, guys? Are you getting it or not? Okay, let me write the simple table creation, and then so this is the assignment for you guys. Okay, what you can do, you can create a table. You can create a table with the column. Okay, what are the columns you have? Name, gender, name, gender, and some salary. Okay, so this is the three columns we have, and so in gender you have the. Let me go on then. So create this table first, and create this table like so. Employee ID, name, and gender, and then salary. You have this one. Okay, so like or else you can use this table. Okay, or else you can use this table. So and wherever you have a male, wherever you have a male, and then I want to update this to the female, and then wherever you have a female, then change it to male. So how you can do that? You have to use the case statement, guys. Okay, you have to use the case statement in the update. Are you getting it? So write this question and then do it. This is a very very important interview question. Okay, this is very very important interview question. Okay, so whenever you have the like this way we use the case statements most of the times. Like case statement where you have the switch in your DAX, right? So we are using the DAX. In DAX we are using the switch, right? So I've explained very clearly the switch statement in the DAX. So like wherever you use the switch statement in the DAX, the same way even we will also use the um, case statement. Case statement is equal to the switch in DAX. Okay, and if if else how to use the if else. Okay, so even guys, someone is unmuted. Please go mute yourself. Rakesh.
Oh, okay.
Okay, the same above case statement. If I want to write in a, if I want to write in a, um, if else statement, how to write this? So the case state, like so, whatever the case statement we have used, if we write that in the if else statement, how to write that? So very simple. So what you can do? This is called a dynamic SQL, guys. Okay, we'll declare and at the rate salary, and that is int. Okay, that is int, and set salary. So whatever the values you want to set, you can go and then set at the rate salary, set at the rate salary equal to some 60,000. Okay, 60,000, just it is there. Okay, if salary, if at the rate salary, if at the rate salary is greater than 10,000, 1 lakh. Okay, if it is greater than 1 lakh, then print. What I am asking, print high salary. Print high salary. Okay, print high salary. Else, else if at the rate salary, else at the rate salary between, right? Between salary between 50 and 70, 50 and 70, then like what is that? Print medium, print medium, and then so else what you want to print? Print low salary. So like this, you will use the if else, guys. You will use the, sorry, not low salary, low salary or something. Okay. So this way, suppose you pass the 60, right? So then definitely what it will print? It will print, okay, this condition will satisfy, and then it will print the medium. Yes or no? But if I, so sorry, it is not, so it should be 1 lakh, right? So if I go with the 60, then definitely it will print medium, right? If I go with the 30, okay, if I go with 30,000, then what it will print, guys? What it will print? Low salary, right? See, it is printing low salary. Okay, so like it is checking the if condition. If the salary is greater than this one, so then it printing it this one. So if I go with the 2 lakhs, if I go with this 2 lakhs, then what it is print? It will print. So the first condition will satisfy and then print the first one. Okay, else it will go with this condition and then it will print this one. Or else, okay, if it is not meeting these two conditions, then it will go with this one and then it will print this one. Okay, so this way, like we can also use the if else. Yeah, we can also use the if else. So case, if, else. So this is the, like, things we have. But from tomorrow onwards, what we'll do, we'll go with the ss classes, guys. Okay, so like we have some more classes also there in SQL Server, but going forward you will understand very clearly. So wherever you have something, if I not covered, so definitely you will understand going forward. Yeah, that's all for today, guys. We'll catch up tomorrow then. So
Is there
tomorrow
any installation for SSS, sir?
exercise. What?
Installation is there?
అర్థం కాలేదు.